So welcome again to Chemistry for Engineers. For our first topic, it will be on the basics of chemistry. Under this, we have the study of chemistry, the science of chemistry, etc. And these are the supposed learning outcomes after finishing the topic. Before we get to the study of chemistry, we should look at how it came about. So first we have mathematics, which is the fundamental basis of all sciences. So mathematics is used, for example, to calculate the area under the curve, the mathematical representation of how waves behave. Then we move on to physics, which makes use of the mathematical properties of things. So we use them to interpret how things interact with each other. For example, here we have the atom. An atom essentially is made up of empty space, but at a quantum level, it is not actually empty. So we see here the energy density inside the atom. And we can also see the fluctuations in the quantum field. And here we also have the quantum entanglement. And this are the quarks that make up the particles we have in the atom, specifically neutrons, electrons, and protons. So building on physics, we now have chemistry, which, if you really think about it, that both of them are actually very related. Chemistry builds on physics, for example, the bonds between elements and compounds. It's actually governed by the physics of intermolecular forces. So physics essentially what makes them come together as a compound. So we have here an example or the visualizations of an atom. So in reality, this is how they look like. And we have here the hydrogen molecule. You can see how it attracts and repels from each other, forming the bond that connects individual hydrogen atoms. So chemistry, as we know it, it is mostly the study of reactions, how they happen. For example, we have here the reaction of ozone depletion. We have here a pollutant, which is chlorofluorocarbon. When it interacts with the sun or the UV radiation, it releases a chlorine atom, which has one extra electron. So when it interacts with the ozone compound, it brings with it one oxygen atom. Then it becomes the oxygen atom, the O2 as we know it. So, na siya. And we also have here a relatively large compound, which is vitamin B12. So building on chemistry, our biology emerges. So how does that happen? The reactions that happen in our body, the reactions that happen in animals, in plants, and in other living things, it is actually governed by chemistry. Without chemistry, we will not be alive. So for us to appreciate chemistry, especially when it is applied to engineering, so we look at examples of these. So example natay doping sa semiconductors. Semiconductors are very important in the function of our computers, our cell phones, essentially any device that runs on electronics. So again, natay doping. Ang semiconductors usually it is made up of silicon atoms. Ang meaning sa doping kay mag-inject tag foreign material sa usa ka substance para mo improve yung performance or properties. So sa N-type semiconductor, mag-inject tag atom or mag-add tag element na naay 5 valence electrons. Ang valence electrons ay katong mga electrons na readily mag-bond with other elements. So sa N-type, it is usually doped with phosphorus. It has 5 valence electrons. So katong extra electrons, mao to siya ang flow sa semiconductor, making it possible nga mo conduct po siya electricity and other entity. So ang sa p-type sad, it is injected with an element that has 3 valence electrons. So usually ilang ginagamit ani kay boron. So if sa p-type semiconductor natay vacant na hole. So kini siya nga hole ga-move ni sa whole semiconductor, making it possible for electrons to flow. So essentially, ang importance lang din sa doping para free ang electrons mag-flow. Kaya naman tayo extra electrons sa N-type while sa P-type natin vacant holes which electrons can move into. So semiconductors made possible the manufacturing of transistors. So kining mga transistors mo na siya atong ginagamit sa atong computers para mag-switch on and off. So ang common configurations transistors kinatay N-type semiconductor siya mag then P-type then na po N-type there. So basically naka-sandwich sila. So ngano ang anak man. Diba nag-ingon ta ganina nga natay extra electron. So sa gikan sa N-type natay extra electron, so mo-flow siya to our P-type semiconductor kanang siya vacant na hole until maabot na po siya sa other N-type semiconductor. So at some point, dili na maka-flow ang electrons kaya na-fill naman niya ang holes sa P-type semiconductor. So meaning kung dili na mag-flow ang electrons, meaning naka-off ang switch. Para po i-turn on ang switch, mag-apply tag voltage in such a way nga ma-overcome to niya ng resistance para mag-flow na po ang electrons. With that, naka-turn on siya. So ang current flow and no current flow, these make up the binary digits we usually see sa pag-program sa computers. So sa civil engineering, makita ko na to ang chemistry. For example, sa atong buildings kay essentially ginagamit nato ang take advantage ta sa properties ng material in order to build the things we want. And example na important consideration when we are building stuff ang corrosion. For example, we have an iron bar which readily oxidizes in the presence of oxygen. In that way, it will free up 4 electrons. So kani siya, flow ni siya throughout the metal. So when that happens, ang Fe2 plus, kay mo migrate po siya sa water droplet. Then it reacts with oxygen and water to form rust. Mao na ni siya atong iron oxide and hydrate. So for mechanical engineering, chemistry is also present. For example, the principle of combustion, it is used in our engines. So we have here an example of a four-stroke engine which uses diesel to power up a car. So an example again would be on material science. Mechanical engineers are also involved in building rockets. So we take advantage of materials that can withstand so much heat in such a way that it would make the takeoff of rockets possible. And another newly discovered compound, which is given by the chemical formula, it was found that it has low thermal conductivity. So kung moingon tag thermal conductivity, it is the property of a material in which how heat travels in a material. So kung moingon tag low conductivity, dili dali mag-heat up ang isa ka material. And its potential application, it is on the recovery of waste heat to convert it to electricity. Now let's discuss the chemistry in our body, the emotions we feel, and in digestion. So in love, chemistry also participates a lot. Love is governed by the chemical reactions happening in our brains. According to scientists, love can be divided or can be subdivided into 3 categories, which are lust, attraction, and attachment. When we feel lust, the estrogen and testosterone levels in our body increases. And in that way, it increases our sex drive. Next, when we feel or when we are attracted to a person, the brain also releases chemicals such as dopamine and norepinephrine. However, when we are attracted to someone, there is a decrease in serotonin. So ang effect ani kay dili nakakatulgon, then decrease po din ang taste of food, meaning dili kayo kagutomon. Ang serotonin siya kay gina-produce mainly sa atong intestine, sulod sa atong intestine. Mao po ng rason if dagan kitag nakaon, then feel din nato katulgon na denta. Ang responsible ani nga chemical kay ang serotonin. Mano siyang gakos sa sleepiness after eating. So sa attachment na po, kay ga-release po na itong brain ang oxytocin and vasopressin. Then by the way, kining mga chemicals kay ginasecrete ni sa atong gland sa atong body. So na may effect ani sa tuwa if kung in love ka. So if taas atong estrogen o testosterone, kay ga-increase atong sex drive. However, at the same time, it shuts off the logical parts of our brain. So in simple words, ang love makes us dumb. Bali, makabugo ang love. Para sa essentially ang conclusion sa ilang study. Sa digestion na po, we can notice na kung gutomon ta, kay mura tag sa puton, na po'y gina-release na chemical atong glands, which is cortisol. Ini siya nga hormone, cortisol. It is also known as a stress hormone. So it triggers emotions such as anger, kanang irritation, kung ma-annoy ka. And it especially happens when we are hungry. So explanation nga no, mura tag sa puton, if gutom ta, ang cortisol ang responsible ana. So chemistry is the study of matter and the changes that matter undergoes. So ginatawag po ang chemistry as a central science nga naman kay ginarelate niya ang tanan fields of science. Na siya chemistry ay na siya physics, siya biology, agriculture, geology. Bali, it is the central or the main aspect of other sciences. And ginarelate niya ang other fields. So natay 3 levels of understanding or perspectives. The macroscopic, microscopic, and symbolic understanding. Is observed through 2 types of changes. We have physical changes and chemical changes. Ang physical changes, it refers to a change na dili magbag-o ang entity sa usa ka substance. For example, kung i-cut mo ang paper ra Japon siya. Kung bason mo ang paper ra Japon siya. Ang physical changes, it refers to a change that differs the entity of a substance. For example, if sunugon nimo ang paper, it becomes ash and carbon dioxide. So nag-change ang entity sa paper. It has become carbon dioxide and ash. So we have our properties. First, we have our physical properties that refer to variables or parameters of matter that can be measured without changing the identity of the substance. So an example, only can density sa object, mass, color, viscosity, hardness, and temperature. Kani sila ma-measure ni sila without changing the identity of the substance. Maora Japon siya kung imo siyang i-measure. Ang aluminum Japon siya. Then we have properties which are determined only by observing how a substance changes its identity in chemical reactions. Ang example sa chemical properties kaya ang flammability sa usa ka substance. For example, the ability of a compound to burn in oxygen. So combustible ba siya? Ang second kay ang reactivity sa usa ka material. We have here ang reactivity sa aluminum metal when it reacts to acid. When it reacts with acid. And interaction pod sa iron ug oxygen that makes rusting possible. So when we are talking about the study of matter, it has fundamental states of matter, which is solid, liquid, and gas. Though we are aware that there are other phases of matter that currently exist, and scientists are continuing to discover other phases of matter. So mao ni sila ang fundamental states of matter. As we know, it solid, liquid, gas. So as you can see sa solid state, kay kami siya vibrate and closely packed sila. So it takes up a shape. And by the way, ang atoms, kay permi ni sila vibrate. Then sa liquid state po, kay ga-assume siya sa shape, sa portion of the container they fill. The gases po, they expand to occupy a space. So we move on to the atomic structure. So we have here the electrons, proton, and neutron. So the electron was discovered using a cathode ray tube by J.J. Thomson, and the charge and mass was determined also. Following that, the proton was discovered by Ernest Rutherford by doing the alpha scattering experiment. Then lastly, the neutron was discovered by James Chadwick. So atong electrons ga-exist siya as a wave, any particle at the same time. So as we can see, if a particle is only a particle, in ano yung behavior, makita nato ang imprints sa particle na scattered kayo. Random na sila. So when a wave interacts with an object, kanang wave lang dyan siya, we will see this behavior. Natin mga interferences. So wave, then mo din yung behavior or imprints na itong makita. So when a quantum object behaves, example, ang electron, minani yung behavior. Musugod siya as wave. Then kung i-observe na siya, ayaw din na ito makita kung asa siya, kung asa ang electron. So ang imprints na po sa electrons kay murag sa wave. So basically, it exists as a wave and a particle at the same time. So matter is composed of atoms that retain the chemical identity they represent. An element, on the other hand, is composed of atoms. And when group of elements are held together, we have our molecules. So matter can be categ- So ang matter pwede siya i-categorize into two. Natay substance and mixture. Ang substance, it is a form of matter that has indefinite or constant composition and distinct properties. An example ani kay atong elements, gold, hydrogen, then atong compounds, we have ammonia, glucose. Ang mixture, on the other hand, it is a combination of two or more substances that retain their distinct identities. So ang example ani kay atong gravel, so natay rocks and sand mixed together. Atong air, it is a mixture of oxygen, nitrogen, argon, and other gases found in the atmosphere. Napud kay cement, mixture yapon ang cement. So under sa substance, it can be further divided into two, the element and the compound. The element refers to a substance that cannot be separated into simpler substances by chemical means. So as is na siya. Wala siya building blocks of substances. So one na siya ang hydrogen, sodium, and other elements found in the periodic table. Compound, on the other hand, it is a substance that is composed of atoms of two or more elements chemically united in fixed proportions. So in other words, compounds are made by fusing elements together or bonding them together. And then separate an element from a compound through chemical means. Under mixture, we also have two categories, which are the homogeneous and heterogeneous mixture. Homogeneous, I think we are already familiar with it, which is ang composition sa mixture kay same throughout. Ang example ani kay ang air. Then as a heterogeneous mixture, the composition is not uniform. So meaning makita nimo ang differences sa substances na composed ato. Dayon, ang in-between sa homogeneous o heterogeneous mixture, we have the colloid. Only siya at a macroscopic level, we may see it as homogeneous. For example, atong mayonnaise. Pero at the microscopic level, makita nato na separate day ang oil o ang solid na part. Then we can separate substances from mixtures through physical means. For example, filtration, condensation, and other methods that can be employed. Ang example sa chemical means, kinatay combustion, or i-react nato in such a way na makuha ang element na atong gusto. So we have here the periodic table of elements. The table is arranged in such a way that elements that belong to a particular group have the same properties. For example, here we have the S block, which refers to how electrons are arranged in itself. So kini S, D, E, F block, they refer to the quantum arrangement of atoms in these certain elements. So first, I have mentioned earlier that kini mga elements, pig-arrange sila in such a way na same sila properties. So natay alkali metals which have one valence electron, they will readily give out one valence electron for bonding. And these elements are highly reactive when exposed to oxygen or water. And they readily form hydroxides. For example, ang sodium violent kini siya mo react with water, then it produces sodium hydroxide. The second group, which is the alkali earth metals, have two valence electrons. They readily give out two electrons for bonding. So these are also reactive, but less reactive kaysa sa alkali metals. And they also form hydroxides. So kung mo-react sila, for example, magnesium with water, kay magka-form siya of magnesium hydroxide. So we have here another part kay ang transition metals. Muna sila tanan metals. And we can usually use these elements as catalysts. For example, atom, rhodium, palladium, nickel, vanadium. Kaya ginagamit na to ni sila sa sakyanan para i-convert ang carbon monoxide into carbon dioxide para less harmful na po siya sa atong environment. Second, the fourth rather, we have the boron group, which gives out 3 valence electrons for bonding. So common yung Japan nilang element. Ang nakalahi lang sila kay si boron, which exists as a metalloid, meaning in between siya sa pagka-metal o pagka-non-metal. Other than that, si aluminum, palladium, kini sila, yung mga metals na sila. Next, ang carbon group, it gives out 4 electrons for bonding. And we have the nitrogen group, which gives out 5 valence electrons. We have our oxygen group, which gives out 6 valence electrons. And we have the halogens that have 7 valence electrons for bonding. And usually they are highly electronegative, meaning they can accept electrons. Then we have the noble gases. Muna sila ang pinaka-stable na elements that we have in the periodic table. Ang neon, for example, ginagamit na to ni sila sa neon lights. Ang radon, for example, usually atong source ani kay gikan sa soil. And radioactive din siya when it exists sa iyang natural form. And so we have here our lanthanides o ang actinides. Usually, kini sila tanan kay radioactive sa ilang natural form. So we have here, for example, uranium, which is used in our nuclear reactors to produce energy. So kini sila, if mag-emit ni sila radiation, taas kayong energy na ma-release in such a way na maka-knock out sila out particles sa isa ka atom. Which then, kung ma-expose ta sa radiation, di ba maka-knock out man siya electrons, neutrons, protons, it could then cause cancer sa ato or radiation burns. So at a microscopic level, we can see the solid state as irregular ordered structure. Or liquid, inay lang yan movement in such a way na naka-take up siya sa space na contain. Then sa gas, behave sila in such a way that they are widely separated and move independently of one another. So during physical change, again, the chemical composition does not change. Ang heating sa liquid water, nandiyan pa siya pero sa yung vapor form. Sa chemical change, again, it changes the chemical composition. For example, if we apply electricity to water, it can for example, we have electricity. When applied to water, it separates into oxygen and hydrogen molecules. So problem 1. A candle suspended above boiling water could be used to test a hypothesis about the chemical composition of the bubbles that rise from boiling water. What would be the observed scenario if the bubbles were composed of water, hydrogen, and oxygen? So if the composition of the bubbles were water, kay mapalong ang candle. Kay masuffocate niya ang fire, ang candle, so mapalong siya. Bali, ma-push away niya ang oxygen molecules, which makes fire possible. If hydrogen were the composition of the bubbles, mo continue na Japon o siga ang fire. Kaya flammable man ang hydrogen, o siga man siya, it burns with oxygen. So kung oxygen po, dili po siya mapalong. Kaya again, important ang oxygen para i-maintain ang fire. So muna siya ang answer essentially. So for the symbolic representation, we use element abbreviations which are found in the periodic table. For example, we have aluminum, which is represented by Al, and its compound aluminum oxide, which is Al2O3. So mali sila at a microscopic level. Mali lang arrangement sa ilang atoms. So at a microscopic level, we can see that we are using electricity to separate hydrogen and oxygen from each other. At a microscopic level, mao na ninyo ito makita ang two molecules of water separates into two molecules of hydrogen and one molecule of oxygen. Then using the symbolic or elemental abbreviation of these compounds, mao na din natin H2O in liquid form, H2 in gaseous form, and O2 in gaseous form. So ayun. In that case, we will end here for now for our first lecture, and we will continue on to the next.